Hey everybody, I'm going to go through the 10.1 homework quiz along with notes kind of side by side to save you a little video watching time because it is so similar to what we did last week with confidence intervals and hypothesis tests. It's just now a difference of two proportions, but everything else is really one and the same. So in question one on the homework quiz says, according to the manufacturer, 20% of plain M&Ms are orange and 23% of peanut M&Ms are orange. Suppose you were able to take a simple random sample of 240 candies, 240 of each candy. Let P1 be the sample proportion of plain M&Ms that are orange and P2 be the sample proportion of peanut M&Ms that are orange. Describe the sampling distribution of P1 minus P2, or the difference of those proportions. I'm going to go back to the notes I posted Sunday morning. And here in the guided notes, they're filled in for you in this version, but the guided notes says the sampling distribution of two proportions, its shape is normal when NP and NQ are both at least 10. The center is the difference of the proportions, and then the spread, the formula for standard deviation is PQ over N1, P1Q1 over N1 plus P2Q2 over N2, and then the square root. So formulas are all very similar wise, even the shape being normal in the same normal condition. So it's describing a distribution that's shape, center, and spread. So shape, I'm going to check the normal condition to say it's normal. So N1, P1. Here that's 240 times 0.2. And that is 48. And that means N1Q1 is 240 times 0.8. And that's 192, so that's met. And I got to check them for the second sample, so N2, P2. So this is peanut M&M. So N2, the samples were the same size, so it's still 240 times 0.23. That gives us 55.2. And then N2Q2. That's going to give us 240 times 0.78. Or sorry, 77, and if you compute that, that gives you 184.8. So I had to show that those conditions were met, and that allows me to say that this shape is normal. And then the center of the distribution of the mean is just going to be the difference of those proportions. So again, if I go back to the notes, the center is the mean of the sampling distribution, is the difference of the proportions. So P1 minus P2, so 0.2 minus 0.23. That gives me a center of negative 0.3, and that's fine. That just means the P1 was smaller than P2. And then spread. My new formula for standard deviation is square root P1Q1 over N1. I'm just going to fill them in here. But I'll flip back to the formula real quick. Here's the formula. You don't have to memorize it. So P1Q1 over N1 plus P2Q2 over N2, and then take the square root. These are both 240 for my sample sizes. So 0.2 times 0.8 over 240, and then 0.23, wow, times 0.77 over 240, and you do that in the calculator, it gives you a standard deviation of 0.037. And if you're having trouble reading my writing with my finger here, I also attached in Google Classroom the filled in version of the quiz. So there's my sampling distribution for the difference of p hats. And then B, what's the probability you select a higher proportion of plain orange M&Ms than peanut orange M&Ms? So we kind of seen this back with combining random variables. What I'm really asking here is, what's the probability that I get a P1 hat that's bigger than a P2 hat? And we found back with sampling distributions, or sorry, back with combining random variables, that I can't find this probability, but if you think about what we just did up here, we can do the probability of P1 minus P2. So P1 hat minus P2 hat. Meaning I subtract this P2 to the other side, and I can find, well, what's the probability that difference is bigger than 0? And that's what we're going to find here. So if I go back to my sampling distribution we found above, so everything from up here is coming back to a picture. The mean was negative 0.3. And if I think, well, where's 0? Well, 0 is above negative 0.3, so here's 0, somewhere up here. And I want greater, so I shade to the right. And if you do a norm CDF here, menu, statistics, distributions, norm CDF, my lower bound's 0, my upper bound's George Sink. Negative 0.3 was my mean, and the standard deviation was 0.037. And I get the probability, wow, very, very small probability. Let me see if I type something in wrong. All right, so my mistake was, this is 0.03. Well, I had it wrong up here too. Go back to my calculations. And that looks better. So 0.208, or sorry, 0.209. That's the probability that the proportion of orange is more for plain M&Ms than peanut M&Ms. All right, question 2 is going to ask us to carry out a hypothesis test, and it might do a confidence interval as well. So state policeman is a pet theory that people who drive red cars are more likely to drive too fast. On his day off, he borrows the department's radar gun, parks his car in a rest area, and measures the proportion of red and non-red cars that are driving too fast. To produce the random sample, he rolls a die and only includes cars in his sample if he rolls a 5 or a 6. He finds that 18 of 28 red cars are driving too fast, and 75 of 205 other cars are driving too fast. Is this convincing evidence that people who drive red cars are more likely to drive too fast? Support your conclusion with a significance test using alpha equal to 0.05. So let me flip back to the notes real quick. So if I look at these notes and I go to significance tests. So for a significance test or a hypothesis test with a difference of proportions, we're always going to assume in the null hypothesis there's no difference, or that the difference equals 0. Or alternatively, sometimes you'll see it written this way, that the proportions are the same. All right, that means if you subtract one from the other, you get 0. So I'm always going to list my null hypothesis as the difference equal to 0. And then the alternative, just like before, could be a greater than, a less than, or a not equal to. And we have the same conditions as before. So when we do our state plan do here, the state we're going to perform a hypothesis test at the alpha equal to 0.05 level for the true mean difference in proportions of red cars driving too fast. In proportions of red cars and non-red cars that drive too fast. And our null here will be that the difference, P1 minus P2 equals 0. Our alternative, he thinks, let's call red cars, we'll call red cars P1. And other cars P2. So P1 minus P2 is going to be a greater than 0 here if I think red cars are more likely to speed. And then my plan, check conditions. I'm just going to do this quickly because I'm running out of time on my video already. So if you check my conditions, let me scroll back up here to my conditions. They're the same as before. You just have to check them twice. So you're like Santa. So check your conditions, check them twice. So random, you have to say that both samples were random. So here, him rolling the die and only picking cars if it's a 5 or a 6, that's him randomizing his sample. So random is met for both. Normal, you'd have to do NP1. So in this problem, NP1 would be the 18, and then NP2 is 10. Right, the rest of the cars, that's successes and failures, they're both at least 10. And then NP2, 75 out of 205, that's bigger than 10. The rest is obviously also bigger than 10. So normal conditions met. So random's met, normal's met, independent. I'd say both these samples are less than 10% of cars on this highway. So we'll say conditions are met. You'd have to show that. I just said it out loud to save some time. And then the do, we could do like I did in the problem before with the sampling distribution, but it's a little bit easier here if you use the shortcut in the calculator, especially if you're given the proportions or given the actual number of successes. So I'm going to do it in the calculator. So menu 6, 7. This is a 2-prop z-test. X1 was 18 of 28. X2 was 75 of 205. And we want to know is P1 greater than P2. So here's my result. I got a p-value of 0.002. So the do is those calculations I just did in the calculator. Sufficient work is just listing really everything that came out on that screen. But the most important part was that p-value. So here at the do, we got a p-value of 0.002. So based on our alpha level of 0.05, our conclude here is we're going to reject the null hypothesis. So because our p-value is less than our alpha 0.05, we reject the null hypothesis and conclude that the proportion of red cars speeding is greater than other colored cars. And then construct and interpret a 95% confidence interval. We already did all the conditions. The only thing left to do here is go back to the calculator, menu, statistics, confidence intervals. We're doing a 2-prop z interval. I'm entering the same things we just entered. And 95%. So my interval is 0.0888 to 0.466. And then our conclude is we are 95% confident the true difference in proportions of red cars that drive too fast and other cars